Hi viewers, today we will start here uh, the concept about the free fall of lighter and heavier bodies under the action of gravity, right? So, free fall of lighter and heavier bodies. Heavier bodies are objects under gravity in route. So, in order to study the free fall of, in order to understand the free fall of lighter and heavier bodies under the action of gravity. So, first of all, you must know that free fall means when only the gravitational force acts on the bodies and the bodies fall only under the action of gravity. That is called free fall of lighter or of heavier bodies, right? Okay, so in order to study the free fall of lighter and heavier bodies, we can consider Newton's law of gravitation, and this law involves two types of proportionalities. They are number one, that the force of gravity, the gravitational force between the two masses, is directly proportional to the product of the masses, right? And the second proportionality is that the force, gravitational force, is inversely proportional to the scale of the distance between the masses of the two bodies, right? And by combining these two proportionalities, we get a composite proportionality that is proportional to F proportional to M1, M2 over R square, right? And here we can, you can say, uh, finish the proportionality symbol by involving the constant of proportionality. That means the F will be equal to, let's say, the name of the proportionality constant, capital G. So then this becomes capital G M1 M2 over R square, right? Okay. So this equation F is equal to G M1 M2 over R square. This is the equation according to Newton's law of gravitation. Here, capital G is you can say capital G is Newton's gravitation constant, right? Newton's gravitation constant, a gravitational constant, gravitational constant. Okay. Now, if there are two bodies, let's say, let us have two bodies. Let us consider two bodies. Let us consider lighter and heavier bodies. Consider lighter and heavier bodies. Lighter and heavier bodies. Heavier bodies. Right? Having masses. Having masses M1 and M2 respectively. That means M1 is less than M2, right? Means the body having mass M1 is lighter and the body having the mass M2 is heavier, okay? Now, according to Newton's second law of motion, right? According to Newton's second law. According to Newton's second law. Second law of motion, the force by the gravity, by you can say by the gravity of Earth, let's say by Earth, let's say this is the Earth whose mass is capital M, and over here the body having mass is small m1 is this one, then the force of gravity by Earth on the body m1 can be written as, that is you can say F that is Fm1, that is equal to capital T m1, and the second mass will be the mass of Earth. And let's say the distance between their centers from here to here, center to center, the distances are, okay, so here the force will be F for m1, and according to this relation is according to Newton's law of gravitation, and according to Newton's second law, this force becomes you can say F also Fm1, the force on the body having mass m1, that will be equal to its mass into the acceleration produced by the force of gravity. That, let's say that acceleration is t, right? So by equating the equation 1 and equation 2, prepared by equating equation 1 and 2, the right sides, by equating the right sides of equation 1 and 2, we get m1t equals capital T m1 capital M over r squared. So this gives us the m1 is cancelled on both sides. So G comes to be capital T M over r squared, right? Now, for the second body, which is the heavier one, whose mass is m2, right? For you can say for the mass m2, for the mass m2, right? In the same way, we will capture the force on the mass m2 to be equal to capital T m2 into the mass of Earth over the distance between their centers, right? Okay, so here in this case, according to Newton's second law, you can say also this force on m2 by the Earth, that will be the mass of the body into the acceleration produced due to the force of gravity of Earth on the body m2. Now you can compare these two equations, let's say equation 3 and equation 4. You can compare the right sides of equation 3 and equation 4, and that gives us m2t equals capital T m2 capital M over r squared, right? So here m2 will be cancelled on both sides. So this gives us the value of t to be equal to capital T capital M over r squared, right? And keep in mind here, the distance r is same distance as the distance in case of m1. So means the centers of m1 and m2 are at the same distance from the center of Earth. In that case, the value of g will be same. That means g of m1 will be equal to g of m2. This can be concluded from these two equations. So let's say equation B and the above one. That is let's say the equation A. This one. Look at, okay. This is let's say the equation A. And in order to differentiate, we can name this acceleration to be gm1. So that's why this is gm1, right? And the acceleration which is present in the equation B, that can be named as, let's say, gm2. So this is gm2. So comparing the right sides of equation A and B means equation A and B implies A and B, sorry. Equation A and B, equations A and B implies that gm1 is equal to gm2. Means this means that lighter and heavier bodies, lighter and heavier bodies are objects are accelerated at the same rate, at the same rate in vacuum. This is special thing that we are considering here in the vacuum. At the same rate, right? When left to fall at the same height, at the same distance, same distance from center of Earth, right? Our center of gravity. Okay, this means if this is the body, this is the bigger body, Earth, and there are two bodies. One is the smaller one, M1, and the other one is bigger one. So let's say M2, so that their centers are at the same distance from the center of Earth. Let's say the same distance are okay. So in this case, these bodies, irrespective of their different masses, will fall down simultaneously at the ground surface. And this can be seen from the simulation also. From the simulation of the free fall of the lighter and heavier bodies, a reality, this aspect can be, you can say, better understood. So we can see simulation here. Let's say the mass of the body is the mass of the lighter body is, let's say, 2 kg, and the mass of heavy body is, let's say, 10 kg. Even then, you can say if we let them fall freely fall only under the action of gravitational force of Earth, so we'll see that both bodies will fall down simultaneously. That means in vacuum, lighter and heavy bodies speed up at the same rate under the gravity. Okay, so you can change the masses again and again, right? You can see here that the two bodies means fall down at the same rate. Even if you change the masses, right? So in this case, we can check. So it means in vacuum, lighter and heavy bodies accelerate at the same rate under the action of gravity. That's all. Thank you.